In this video, I wanted to talk a little bit about the random variable distributions that we know, and then lead into one that we haven't learned yet. It's estimated 45% of students plan to go to a four-year college at a certain high school. If you interview 10 students, find the probability that, okay, so this is a binomial setting. I hope you remember that. That was where we were given a probability, right? P is 0.45. So the probability of that not happening, that the complement, often denoted with Q, was 0.55. And the next piece of information was that we were given a sample, n equals 10. And that 45 and 55, we assume independence. We don't think that just because we got 6 in a row that felt or that we're doing something that the next one would change. We use those numbers for the whole thing. And you might remember the way we wrote this, the way you could write this is you'd say, okay, I've got 5 that plan to go, so 0.45 to the 5th power. That means that I've got 0.55. I've got the ones that don't plan on going. And then I had to count how many different ways using a combination. I said I have 10 students, and I'm picking how many, or I'm trying to find how many ways there are to get 5 out of 10, all the different arrangements. So that was the way that you could have written this. And again, this was saying, if you didn't have this at the end, it was saying the first 5 were going and the next 5 weren't. And we need to say, nah, it could have been in any order. So let's count up how many different orders there are. For the AP exam, how we would write this is we'd say, okay, it's a binomial setting where the number was 10. Probability was 0.45, and the value we were interested in was 5. Okay. Next up, none plan to go to a four-year college. Okay, so for that one, we would have said, binomial, n was 10, probability is 0.45, and k is 0. All of them, okay, so all of them, binomial setting, n is 10. 0.45, k equals all 10. And I'm not typing all these in. I would rely on you to be able to do that. That is something, you got ready to do in the AP exam. You went to Binom PDF and typed that in. At least 3 go to college. So for this one, now, at least this would be a Binom CDF situation. So again, we got Binom. That's like that. Now, what's the probability? It takes 5 students before you find one. So this is a geometric setting. And if you remember, a geometric, it started a lot like a binomial in that it still had that p equals 0.45. We had the complement. We had independence, so we were just going to leave the numbers the same. We weren't going to change them. But the object of interest was not how many out of a total, it was when is the first. Now, this is, this actually is pretty easy to just do by hand. You just say, well, if it takes 5 students to get the first, that means the first 4 students said no. So there's 4 students that said no, followed by the student that said yes. And that's it. You don't have to do this, thing to count the number of orders because this is the order. This was it exactly. If you wanted to use the same type of notation, you would say this is a geometric setting where the probability is 0.45 and the value we are interested in is 5. Okay? So a hypergeometric situation. 25 people are in a room. 15 are females, 10 are males, and 5 are picked for a committee. Okay, so I guess first of all, why isn't it geometric? Hopefully the very first thing you notice is, well, they gave us a total number of people. Okay, so already we're like, okay, well, we're picking 5 out of 25. This is not geometric. But then you think, well, is it binomial? And the answer is no, because the minute we pick a person, let's say we picked a female, well, now there are only 24 people left and 14 are female. The probability has changed. So And that, of course, that actually applies to geometric as well. It's not geometric for this. I mean, that's another reason it's not geometric. But it has to do with the fact that the probability is changing. So the hypergeometric setting, I think the big thing to remember is probability at its heart is we count up how many ways there are to have success or have what we're looking for and divide that by the total number of ways there are for something to happen. So in this situation, let's start with the denominator. Find the probability that if we'd pick these 5 people, that all were men. So I begin with a combination of 25 picking 5. So very similar to the situation with binomial where we say, okay, well, I have 25. How many ways are there to get 5 out of the 25? Okay. The numerator is kind of a breakdown of our categories. We say, okay, we had 10 men. How many ways are there to get 5 of them? And we had 15 women. How many ways are there to get none of them? And just as a kind of nice check, notice these two numbers have to add up to be the total group size. And these two numbers, the number picked, have to add up to the total number picked. Now I'm going to set up these other two here, at least these other two, and then I'll show you how to type in this combination thing. All right, but let's set up the next one. Find the probability. It was 2 men and 3 women. Okay, so the bottom remains the same. We still have 25 picking 5. Please note that's the kind of nice notation for a combination. There are other ways to write it, and I'll talk about those in a moment. But you don't put like a division thing in. It's not a fraction, and it's got those parentheses around it that lets us know that it's a combination. All right, so we had 10 men, and we're picking 2. And we have 15 women, and we're picking 3, like that. Now, here, at least 3 women. Well, this is going to be some work, because what we're going to have here is we're going to find the probability of 3 women. So let's do that. Oh, just got done saying don't put a division, then I did it. We got 10 men, pick 2, 15 women, pick 3, plus 25, 5. Getting a little low there and couldn't write, so 25, 5. And for men now, at least 3 men, it could have been more. So I'm going to pick 1 man and 4 women. And of course, then we got to say, well, 25 and 5. You also could have had no men and all women. You'll notice that the common denominator is always the same. You could have actually just put, all of the different ways in the numerators and added those together and then divided by the denominator at the end. Some other ways to write combinations. Write the same thing. You'll see sometimes a combination of 15 choosing 0. You'll see a combination with some subscripts, 15 choosing 0. This is the one that your calculator uses. So let me show you, first of all, how we get that. All right, so you're going to go to the Math and then the PRB menu for probability. You're going to go down to NCR. And actually, I'm going to put that's where it is. And then you can fill in those numbers. We said, well, 15 and 0. Like that. The older style calculators, you'll have to type, they appear actually a thing that says NCR. So you write 15 NCR 0 and it fills in those spots. But that's how you actually calculate that. Okay. All right, so here I've actually typed in the one example that we did with the 2 men and 3 women. Okay, so the red writing, so you can kind of see how I would have typed in the whole thing. Okay, right here. The Twins play games against the Central, East, and West divisions. They play 39 home games against the Central and 21 home games against each of the other 2 divisions. A group of friends buys season tickets that then puts that tickets in a hat. The first person reaches in and is able to pick 8 games. So if you add all those up, again, there are 3 divisions, so 3 divisions. And we're going to pick 8 games out of a hat. So 39 against the Central, 21 against the East, 21 against the West. So a total of 81 home games are going to be played, okay? So what's the probability that all 8 are against the Central? So first thing to do is just say, all right, well, we had 81 games. Pick 8. And the top would be a combination of 39 and 8. And then 21 and 21 is 42, so it'd be 42 and 0. Now, any combination of 42 and 0, like any combination like that comes out to be 1. Find the probability that 4 are against the Central. So this would be 39, 8 on top. And then 42 and 4, because it didn't designate, it just says, 39 and 4. 42 and 4, it didn't designate which other division. It just said, 4 were against the Central. And 81 and 8. Find the probability of 4 against the Central and 2 are against the other divisions. Okay, so now we got, out of the 39 games at the Central, we got 4. Out of the 21 against the East, we got 2. Out of the 21 against the West, we got 2. And again, the total here, 81 and 8. Find the probability that 1 is against the Central. Okay, so we got 39 and 1. 3 against the West, so 21 games, 3. And 4 against the East, so 21 and 4. Our luck would probably be against the Yankees. And 81 and 8. Like that. And again, I'm going to rely on the fact that you could type those in the calculator. But this is the geometric setting. Again, this is just another type of random variable. It's kind of an extension and goes past what the AP exam does, but certainly a good one to know because it's awfully likely in a lot of scenarios that the probabilities do change based on, something being picked and not being able to be picked again.